Now, one of the things that a lot of students don't realize is that there's actually different types of programming. I don't mean different programming languages, and there are definitely lots of programming languages. In fact, there are hundreds of programming languages. But I don't mean that. I'm talking about types of programming and how we can classify what is it that we're doing, how can we kind of break things down into different categories. So let's talk about some of those that we're going to see through a bachelor's in computer science. And even if you were to get a minor in computer science, you would probably be exposed to most of these. Now, this is not an all-inclusive list. This is just the most common types that you're going to see. The first one that you're going to see is what we've already been doing, which is known as procedural programming. And procedural programming says I have some code, and I'm going to run line 1, then line 2, line 3. Maybe line 3 is an if statement, and I'm going to skip down to line 5 or 6, but I'm starting at the top, and I'm running down reading line by line by line. That is procedural programming. Now, procedural programming is everything that we've done so far through these modules. Now we're going to move into functional programming. And functional programming is a second type of programming that is very commonly used, and it actually gets its name and the design based upon mathematics. And that is a math function and a computer function are going to be found to be very, very similar. In a mathematical function, you are going to perform some operation, and if you put in the same data, you should get the same output. And in a computer program, that is also true. When you write a function or call a function, you are going to give it some data potentially, and based upon the data you give it, you should get the same result out. This allows for repeatability. This is very important. And the reason we're going to use functional programming is for several different reasons. Number one is the complexity of our code. As you've been going through various modules, you might have seen that your programs start to get longer and longer and longer. And if you've got a program that's just a couple of lines long, having it as a procedural type of programming, that's easy. In fact, I've seen procedural code that's several hundred lines long. Maybe it's a script that's used to automate some background IT service. But as your code gets more and more complex, you might find that you're going to need to repeat certain sections of code. And you can go and copy and paste it, or you can group it into a function to be called. And by calling it as a separate function, that means that if you need to make a change to that function, every place that you called it gets that update because that repeatability. It even makes writing more complicated code even more efficient because I can break up one large program into functions. I can start to group and organize functions into separate files, and I can hand that off to other people. Now, I know what you're probably thinking right now. Working with other people, I hate that. And I totally get it. As a student, I hated doing group projects. I was the one that found myself a lot of times doing a lot of work while other people slacked off, and that frustrated me. Maybe that's you, or maybe you want to work with other people and the people you want to work with, but you got to try to find time to do it, and I understand those challenges. But I can also tell you, as a professional software developer, I most often worked with other people. And sometimes my teams were very small. It was me and another person. Sometimes there was a dozen or more people on a team working to create a project. In fact, in certain very large applications, you might have teams with sub-teams, and those teams might have 15, 20, 40 people working on it. Think about a large project like a search engine. You're going to have teams that are going to figure out how to go out and scour the internet looking for data. You're going to have teams that are going to look at how do we organize data. We have teams that are going to look at how do you protect against web spam and inappropriate content and age filters. You're going to have other teams that work on how do we do automatic language translations and figure out geolocation to bring in relative sources. And so if you're going to work on a professional development of any size, you quite often work with teams. And so being able to split up the workload and say, hey, you work on this function, I'm going to work on that function, makes your life so much easier. A third type of programming that we often see is object-oriented programming. Now, we're not going to look at object-oriented programming in this course, but object-oriented programming is a different way of looking at it, where with functional programming and procedural programming, you look at what's being done and you look at the actions that are performed typically. With object-oriented programming, we tend to look at the data we're working with and information about that data. What can be done to this data? What can this data do? Those types of things. And I might think about a person, and a person has information about them, what we call attributes. Things such as like a name and a student number and a major. They'll also have things that they can do. So for example, I can change my major, or I can change my mailing address, or I can register for a class. There's lots of other things that a student or a person might be able to go in and do. And so object-oriented programming became very popular in the 1990s as computers started to get more powerful and were able to really support it. There was several things that kind of happened all at one time, which is why it got popular then. Often with that, and in close proximity with that, there is something called event-driven programming. You typically do not see very much of this inside of a traditional bachelor's CS type of program. That's not always the case. We do definitely teach some event-driven programming, but that is, as you might get the idea from its name, based upon something or what we call an event occurring that's going to create a series of actions to perform. Now, what's kind of interesting is that each of these builds upon the other. And so in order to have functional programming, you have to have a set of procedures that can be followed. The difference is that your procedures are now out of step, and it's not reading from top to bottom. You might jump around inside your file by calling these functions, and functions can call other functions that can call other functions. Object-oriented data is made up of variables and attributes that you find in procedural programming. And then they are tied to what we call methods, which is the fancy name for a function in a class. Those are those things that the data can do or have done to it. Event-driven programming typically is a method that's attached to an object or is attached to something, and it's driven and it goes out and it calls a function itself. And so these different types of programming build upon one another. So while we've looked at everything that's been procedural in nature, we're now going to look at functional programming, and we're going to look at how do I write little, essentially mini programs that can be called in other places of our code. Now, a big reason for doing the functional programming, as I mentioned before, was writing your code faster. But a secondary reason, and one that we're going to focus on, is to logically group and organize our code. And so that's going to be part of what's going to help us write faster, more efficient code, is by going, oh, okay, I can subset this. Oh, wait a second, I've already done this piece. Let me go over here and I can do something. Or I might say that I can, hey, go call that function a second or third time, and I can be a little bit faster. So by organizing our code so it's easier to find and easier to write, we're going to make our code much more efficient and, believe it or not, less error prone. You might go, well, why would I? Well, in a procedural language where I can't run out of my linear progression of my code, I have to copy and paste sections of code if I want to repeat it. If I realize I made a mistake, and I could have made a mistake by having maybe a wrong data value in there. I might have hard-coded a constant value. Let's say I typed in by accident pi 3.1514. I got that little bit reversed. Well, I would have to go find every place it has to go fix it. But if I have a function, I put it one place and it stays there. And if I make a change there, every place that I call it gets that automatic update, and therefore our code is more accurate. So it's a lot faster and easier to debug our code, which means our code is going to be more accurate and more correct. So let's take a look at how we're going to build functions. We're going to specifically look in Python, as we've been using this language throughout this course, but let's take a look at how we can go through that process. Now, an interesting thing is we've already looked at how to call functions, and that is how to use them. The term call is just a method for which allows us to go and use a function. It's just programming speak, if you would. And you might say, well, what functions have we used? Well, there's two that we've used specifically, and you might have used others in your practice example problems and stuff like that. The two that we've used specifically are print and input. And let me show you just real quick a simple example. I'm going to say here, if true. Now, this is a really bad if statement because it's always going to run. But it has two things I want to show you. One is commands. If, for, while, those are all commands. Those are things that are built in that the programming language uses. It's not a function that's called, it's a command, it's something that runs, it's native, it's very quick. And you can see that Visual Studio Code highlights those commands in that purple color. We also have true. And true is a Boolean value. Because it's a Boolean value, it is a reserved word. Visual Studio Code is showing it in blue. If you're using Visual Studio or you're using some other editor, it may show you different colors. This is just for descriptive purposes. Okay. If you remember, if we looked at a value and we put in a number or we put in a string, those were all highlighted as different colors for values. However, if we look at print, notice that print is once again a different color. That color means nothing. Okay? That color is just a visual representation to make it easier for you as a developer to identify, is this a command, is this a function, is this a reserved word, is this a value, etc., etc. Now, print is a built-in function, and it's a function that Python gives us, just like the input function, the int function, and the float function. Now, those are some that we've seen. Functions behave differently than a command because a lot of times commands go back to how computer architecture works. And we're not going to worry about how computer architecture works, but just understand that they are a little bit more low level and they operate a little bit faster. Functions allow us to bundle multiple lines of code. You might think, but it's a print command. How difficult can it be? Well, when you realize that Python is running on multiple platforms, it's running on Linux and other Unix derivatives, it's running on Windows and Macintosh and even others out there. Because of that, that function has to be able to operate in any of those different environments. And because Python is an interpreted language, it's a little bit easier for it to do that. But think about what has to happen at that low level. You have to open up a stream of data that goes to what's going to display on the console. And you have to figure out in a windowed environment like Windows or Macintosh, you have to figure out, okay, which window has a console environment, which window is the active window. You have to send a stream of data to that. You have to close the stream when you're done sending that print information. There's a lot of repetitive information that happens just to be able to go in here and say print hello world. And all you see is, hey, I'm just putting in hello world, and when I run this, it's going to show up on my terminal output, or it's going to show up in a terminal window when I run it if I run it separate. That's all you're seeing, but behind the scenes, there's actually a lot of things that are going on. And if you as a developer had to do all those steps every time, it would A, take a lot of time and effort on your part. B, it would open you up to a lot of potential mistakes. Think about something. If you call a print command and pass it a string or a series of values versus maybe taking and having to do 5, 6, 10 steps. So if you think about it, which is easier to make a mistake? Calling a print function where you send it a string or maybe a set of values, or having to choose the right open console window, open up a stream of data, send information, concatenate and bring in extra pieces of information, close that stream, etc., etc. Well, the fewer the steps to perform, the fewer chances there are to create an error, whether it's a simple misspelling or something more complex. This is doing two things for us. Number one, it's reducing the amount of work that we have to do. And all of our functions are going to be the same idea. We want to essentially reduce the amount of work that we have to do, not increase it. We're looking to reduce workload. Because of this, we actually get to see an operation in effect. And this operation, or this methodology, if you prefer, is called the DRY method. DRY is an acronym, DRY. Don't repeat yourself. Now, ironically, you're going to hear me repeat that multiple times in this module. Don't repeat yourself. And that means anytime you see yourself doing the same sections of code over and over again, and think about that print statement. Imagine if you had to print 4, 5, 6 times, and each time you had to write 10 or 15 lines of code. How big would your project be? But if you can put it into a function, where that function's small and simple, it's just a couple of lines, or it's big and complex, doesn't matter. If you can reduce the repetition of what you're writing, you minimize your chance of errors, you improve the speed of writing your code, and those are the two main reasons why you want to use that DRY method. So anytime you see yourself repeating over and over again, whether it's repeating yourself twice or 100 times, you want to look for one of two things. Either A, can this go into a loop? Or B, can this go into a function? And you may find yourself finding out that, hey, it's actually a combination of these. So let's take a look at how we can write our own simple functions. All right, clear out my screen just to make this a little bit easier to work with. And I'm going to define a function. I'm going to say def. And anytime I want to define a function, I always have to use this keyword, def, D-E-F. Notice that this is a keyword, not a command, because it's blue and not purple, okay? Now remember, color is just in Visual Studio Code, but this is just giving us an idea. What we're doing is we're telling Python, hey, I'm going to define something here. There are a couple different things that we can define inside Python. The only one we care about right now are functions. So I'm going to create a hello world function. And you notice, okay, I've got def, I have my function name. You might notice, wait a second, it's underlined there. What's the error? Well, we've given it an identifier name, a function name, but we need to include parentheses. And a parentheses help further tell Python, hey, this is a function. Functions always have those parentheses. Sometimes we have nothing that goes into it. Sometimes, like with the print command, we have things that go into it. They can get pretty complicated, believe it or not, inside of a function. We're just looking at something simple. Now notice that my hello world doesn't have a underline with it, so there's no error there. It likes the fact I've defined a function. At the end of my closing parenthesis, I do have an underline. That's because I'm missing something. And if you think back to our previous two modules where we had if conditions and we had repetition statements, whether it's a for loop or a while loop, we always had a colon at the end. And so I'm just going to put a colon right here. And then just like with our if statements or our loop bodies, whenever we have a body of something, it's going to be indented. In this case, I'm going to say print hello world. Okay. This is super simple, and I understand this is super simple. That's actually kind of what I'm wanting. I'm wanting just something really easy for us to look at right now. So in real life, I wouldn't do this. This is just to demonstrate, okay? So this is a function definition. The simplest form of function definition, we specify def. We give it a function name. Notice that we're using snake case, which is all lowercase and a underscore where a separation between two or more words might be. We have an open and closed parenthesis. We have nothing inside of it because we don't pass anything to it. We'll talk about how we're going to do that in just a little bit. After that, we have our colon. Our colon says, okay, I'm done with this definition. Let's move to our function body. Our function body is indented and we have one or more lines of code. Now, within Python, I can, inside my function body, I can put if statements, I can have loops, I can have a variety of pieces of code. Very, very flexible. We're just using a simple print statement. Now, if I go in here and save this and run it, you're going to see that it goes to run and nothing happens. That's because anytime we create a function, if we want it to run, we have to call it. Okay, so we have to make that function call. The way we're going to do is we're going to come down just a couple of blank lines, just so we get some visual separation. I like to have at least one blank line in between every function. You might say, well, what do you mean every function? Well, it's not uncommon when you start writing a larger program that you're going to have multiple functions inside of it. You can expect 2, 3, 4, 5, 10, 20, 100 functions. You can get very, very large with that. So I just like to create a visual separation, at least one blank line. Then I'm going to call hello world. And you'll notice as I start to type in hello world, it says, hey, wait a second. I know of a function that's called this. Is this what you mean? I can hit the tab key. It's going to fill it out for me. Notice my function call gives the function name exactly as it was typed. So it is case sensitive. And I have my open and close parentheses. Now if I save this and run, you'll notice in the terminal output, it prints hello world. That's because I've actually called this function. In order to use a function, we have to say def, give it a function name, give it a body. If it's missing any of those, it's going to have issues. Then we actually have to call it. Okay. So this is a real simple example of a function. So you might ask, well, how simple is it? Well, there's nothing we pass to it, and then we don't get anything back from it. If you think about the print command, we pass in a string and it prints it to the screen. Well, that string that gets printed out, that's something that's passed into it. That's called a parameter. Likewise, you can get a value returned from a function. You can think of our int function or our float function, how when we pass in a string, it converts it into a different type of data and it returns that back to us, and we can then use that either in our formula or stored in a variable or wherever we need to. So our functions can have a lot of power to them. This is a simple example. Let's see how we can add a little bit of complexity to it to allow our function to do a little bit more. So I'm going to change this up. I'm going to just delete my code here and say def hello, and then I'm going to put in name. Now, name is what we're going to pass in. That's that parameter. And I'm going to put a colon at the end of my function definition. Now I have my body. I'm going to say print hello, comma, name. Okay. You might have noticed when I typed in name, it changed colors a little bit. That's because it picked up a existing value. So it was like, so, hey, you didn't use this parameter and that's a problem. But when I use it, it changes colors. Let me know, oh no, this is okay. So I can kind of hover over this. You'll notice it says, hey, this is a parameter name. When we print, we're going to print hello and get our value. Now I'm going to come down here, once again, kind of skip a blank line, just visual separation. I'm going to say hello. And I'm going to save this real quick. I have not passed in a name. Did this on purpose. I'm going to click run. You're going to notice that it's going to give me an error. And this error says it's missing a required positional argument. And what that means is you can call parameter either by position. It has to be the same order that you pass things in. I recommend that because that's the way most languages run. Okay, if you go to C++ or Java or C#, a lot of those languages, it's based upon what position in the parameter list. You might go, but there's only one parameter. Well, that's easy. You could have functions that have multiple parameters. We'll take a look at that in a second. Okay, so we have hello here, but we didn't give it the required parameter. So let me come in here and give it a required parameter, Fred. Save this, run it, and now it comes up and says hello Fred. If I want to run this again, I can say hello Amy. And if I go and run this, notice it says hello Fred, and then it says hello Amy. Notice that we didn't have to rewrite our hello function again. And this is where functions become a lot more powerful, is because they can take those parameters. And we want to specify something up above, so we did. We always write out the hello. We don't have to write print hello and then a name. We just said hello and give it a name, and it goes and does it for us. As we change the value that we get passed in, it continues to work for us. Let's take a look one more time. I'm going to show you a slight change. I'm going to take and create a variable called my name. Now, my name equals a value of Nate. And I'm going to say hello, my name. Now, just to clean this up, I'm going to do a CLS in my terminal so you can see exactly what happens here, not get lost. I'm going to click run. And notice it takes Fred and Amy, and those are string literals. We pass those values in directly. But then notice it prints out hello Nate. So inside of a function call, when we pass those what we call arguments, the values that we pass to a function are called arguments. When they're received, they're called parameters. Okay? But when we pass an argument to a function, it can be a literal value, something that we manually type in, or it can come from a variable. Well, what does that mean? Well, my variable, I could have gotten that value from like an input statement. So I could have gotten a value, gotten that input, okay, got it from a user, read it from a file, got it from the internet, whatever. I get that information, then I can pass it to a function. And this starts to allow us to be a lot more complex and have a lot more options with what we're going to do. So very interesting work that we can kind of play with here. Always want to kind of keep that in mind. Gives us lots and lots of flexibility. Now let's make another small change to our hello function here. And I'm going to add a new parameter. I'm going to call it times. You might say times, what is that? Well, times is going to be, I want to print hello in the person's name for a given number of times. So notice that inside my parameter list, I have name and I have times. They're separated by a comma. And each one that I want to create that needs to occur, if it's different, is going to be separated by a comma. So I have two separate parameters. Name, which is being used, times, which you notice is more of a blue-gray. That's because we're not using this just yet. If I hover over that, you'll notice it says times is not accessed. It's just like, hey, you've created me, but you're not using me. Are you sure you really want me? Is it okay? Yeah, it is. All right, so we're going to come over here and we're going to say for I in range times. Notice that now times is sticking out and it changes color because we're using it. And come down and print hello. I'm going to call hello. I need to pass in two parameters this time. So I'm going to pass in Beth. I'm going to pass in 3. And let's see what happens. Because we always want to be testing our code. And so the best way to get familiar with our code is to test it and see what happens, see how we have to make little changes. It's a great way to debug our code. Try different values and see what happens. Make sure it's still going to work. I'm going to click run, and notice I print hello Beth, hello Beth, hello Beth. I said 3, it printed 3 times. Remember that range is going to give us 0, 1, 2. Notice that I'm not using I at all, and that's okay. We don't have to use I, all right? This just lets us do it a certain number of times, and that's one of the cool things about that for loop. It's a counting loop. When we need to do something a set number of times, for loop is usually the way to go. Here's a perfect example. Now, I'm going to come over here, and I want to have an optional parameter. So I want to say, yeah, I'll print out hello Beth in this case 3 times, or however many I pass in, but maybe I don't want to have to type in times. Okay, so I'm just going to say equals 1. Notice that it didn't give me any type of error or anything like that. This is setting up a default value, and default values inside of a parameter are really, really powerful. We've actually seen them. So if you remember in our print command, every time we have a comma, it automatically puts a space. There is a default parameter called sep, and it says, hey, it's a space. But you can say sep equals, and you can change that. We looked at how to do that. It's got another default parameter called end, which says when I get to the end of my print command, what do I do? And by default, it goes to the next line. So I'm going to have here in this example, hello Beth, comma 3, and then hello, and I'm going to say Bob. Notice that in my function header, when it gives little hints, it says name equals any. This can be anything it needs to be, and times int equals 1. And so the int equals 1 is kind of specifying, hey, this is what data type I'm expecting to see, and this is a default value. So if I save and run this, you'll notice it prints hello Beth, hello Beth, hello Beth, and then hello Bob. So if we don't give it a number, it uses that default value. If we do give it a parameter, that's when we see however many times we ask for it. Now, we can ask for it 1 time, we can ask for it 100 times. Doesn't matter, okay? So real simple little thing that we can do in this. And we could even, if we want to, maybe do an if statement and say, oh, what happens if times is 0 or a negative value? So we can say, if times is less than 1, times equals 1. We can do little things like that to give us some built-in error checking if we want to. It's obviously not required because maybe we don't want to print out, and so that's why we put 0. That's totally up to you. So just kind of look at, okay, how does this work, and is this what I want it to do? Okay, so we've looked at creating a parameterless function. We've looked at required parameter, multiple required parameters, and having required and optional parameters. By the way, you can have multiple optional parameters inside of your function. You just have to say equals after each one and then start using it. Most languages that have an optional parameter, once you start giving values, everything after that has to have a value. So just keep that in mind. That is a standard rule that you're going to find. It's not just in Python. That's pretty standard. It just makes logistics and understanding what values are required and where does this value go a whole lot easier. Okay, so here's some simple examples of that. And I'm going to start something out here that I have. I have def foo. Okay, so foo is just kind of a junk function. But notice that we're printing out ham inside of foo, and I'm going to call hello world. Remember hello world that we created earlier. I just copy and paste this in just so it's a little bit easier. And then we have another function, def hello world. Okay, so that all makes sense so far. I've got some comments in here, but what I want you to see is when we call our foo function, notice that it calls hello world. So functions can call functions, and we've technically already seen this because in hello world, what do we have? Well, we had it called the print function. That's a built-in function, but it's still a function. So we're creating what's sometimes referred to as user-defined functions, UDF. And so our user-defined functions can call built-in functions or other user-defined functions. And this really, really helps with a lot of complex programming. Now, this is a pretty simple one because all we're still doing is printing out hello world, but I just want to show it real quick. So I'm going to save this and run it. Notice I first call hello world, and that's this first hello world I see in my terminal. Then I call foo, and foo first says print inside of foo about to call hello world. You then see hello world from when it gets printed, and then once it exits, it calls print done calling hello world. And you might think, well, what does that really show? Why is that important? Well, it's important for two things. The first is which I already mentioned. Functions can call other functions. But the second thing, and I think what's even more important, is that we are using this in a procedural fashion. If you remember earlier on in this module, we talked about 4 major types of coding that we typically see as a computer science major working in their bachelor's, and we talked about procedural coding. Procedural coding is where we execute the first line of code, the second line of code, the third line of code, etc. And we said that functional programming is built on top of a lot of the same concepts of procedural programming. It's only when we get to a function that we jump out of order. Well, that means that if we're inside of a function, we are still in that procedural mindset. And so when I call foo, I have to print the first statement, line 2. Then I call hello world. I make that call. I do what it needs me to do. I return back into foo, and then I can go to my next line. So this all happens in a synchronous fashion, or it's going to occur sequentially, one after another. Okay, so when I go make a function call, by default, key very important words there, by default, I'm not going to skip ahead to other pieces of code, okay? It happens in a still basically sequential tone. Now you might say, well, why did I use those words by default? Well, some programming languages, not all, some programming languages allow what they refer to as multi-threaded programming. That allows pieces of code to be run in different parts of the processor so that your code can run much faster. A good example of this might be in a game, and you might have separate sections of code that you want running in different threads or different processes. And you might have like a computer AI that's your bad guy, and he's chasing you around a map. And you've got a graphics processor that's running your screen and rendering it for you. And you've got some audio process that's running that's deciding, do I play that, scary, imposing music because a bad guy's near you, or is it happy, cheery music, or are there sound effects that are playing? On and on and on this can go, okay? So in a multi-threaded environment, you could have processes running simultaneously, but we're not going to be looking at that. That's a much more complex data type. Remember, we crawl before we walk before we run before we start doing sprints and hurdles. And anyone who's done a lot of multi-threaded processing and coding will definitely tell you that's like you're jumping hurdles while juggling and doing some other stuff. It's complicated, very, very powerful, and you wouldn't want to play a game at least a modern game, if you didn't have that capability. So it's great that it's there, but we're not there. We're not going to worry about it. We're not going to even think about it. Okay. So we're just going to focus on this. So what we're going to care about is doing things in a sequential order, where when we call a function, we're going to do that function in its entirety, and then we'll return and keep processing. So there's a couple more things we want to talk about that are real important to understand with functions. First off is that a function can call another function. We've already established this and we've seen this. But did you know that a function can call itself? You might go, wait a second, a function can call its own self? Yes, let's take a quick look at that. So I'm going to say def foo, and say print inside of foo about to call foo. Then I'm going to call foo again. And when a function calls itself, this is known as recursion. This specifically is known as direct recursion, where we are directly calling ourselves. I'm going to add one more print statement, print done calling foo. Come down, blank line. We like that visual separation, and we have foo. Now, I am going to warn you, this is going to give us an error. It's going to give us an error very quickly, but I want to show you what it's doing and why, because it's a real important thing to see, especially if you ever start working with recursive functions. Okay, so you notice that a bunch of stuff printed out, and then we got a boom, track back, most recent call list. We see what's going on. We look all the way down here, we see a recursion error, maximum recursion depth exceeded while calling a Python object. You might say, what? Well, there is a limit to number of function calls you can make. This is a little bit deeper. It talks about something called a call stack. And you might go, well, what's a stack and what's a call stack and what does that mean? Well, a stack is a special data type, and we actually have a class on data structures where we talk about call stacks. And we talk about what a stack is. So we're not going to worry about that at this point. What we need to know is that inside of a function can call a function only so many times, and then it's going to error out. In Python, we're looking at approximately about 995 calls, if I remember correctly. That's still quite a bit, okay? That's a lot of functions calling functions. You might say, well, why did this happen? Well, let's take a look at this real quick, and I can look at my code. If I scroll up on my terminal window, I say inside of foo, about to call foo. So what happens is I've defined my foo function on line 1. I print that inside of foo, about to call foo on line 2. I then call foo. Well, notice that because I call foo, it's a new function call. I start this process over again. I don't keep doing the next set of statements. Okay, remember, I got to wait till foo is done. So I then call foo. Well, what does it do? It says, well, I'm starting again. Print inside of foo, about to call foo, and then it calls foo. And it does this over and over again until I get that upper limit. I never exit out. And because I don't exit out, I never get out of one function call to go and be able to finish. If you notice through my printouts, you'll see there's never any done calling foo listed. Okay, so this is what's known as an infinite recursion. So if you remember in our previous module, we talked about infinite loops. A lot of times it's a while loop and we forget to update what our condition statement is checking. An infinite recursion is a similar type of thing. We have here a recursive statement that constantly calls our function, and we never ever check to say, hey, should we be done with this? So let's do this real quick. And I'm going to come in here and say counter equals 5. And I'm just going to give it this optional parameter. I'm going to say if counter is greater than 0, then I'm going to do all this stuff. Okay, and so I had to indent this. Now, right now, this still hasn't made a change because I need to pass in counter to my calling foo, but I don't want to pass in counter. I want to pass in counter -1. So what's going to happen is it's going to subtract 1 and then it's going to call foo. So it's going to do that mathematical operation first, then call our function. So let's do a CLS in our terminal window. Just kind of clean up that mess. Now if we run it, notice I'm inside of foo, about to call foo. I do this multiple times. That's because every time I go inside of foo, I'm not done. I'm calling it that separate time. But I get to that 5th time and my counter has been counting down. And now I'm no longer going to be doing it. So now I'm done calling foo. And you notice it prints the same number of times I said I'm inside of foo, I'm about to call foo. So this little change lets us check to say, hey, do we still need to be calling this recursive function? And this is very, very important. Now, the next thing I want to show you real quickly is talking about the scope of variables. So here I have a counter. Notice that it's created as a parameter, it gets passed in. It's used inside of foo. I call my foo here. I might want to say, hey, what was counter when it got done? So I say print counter. And you should kind of see right away, wait a second, there's an underline there. Visual Studio Code's not liking this. And if I hover over this error, it's going to say counter is not defined. And you go, wait a second, yes it is. Let me check and make sure I got it spelled right. It is. Why can it not see it? Well, that's actually exactly what it is. It's the fact that it can't see that variable. That variable was declared and defined inside of our foo function. That means its scope is local. Local meaning it's local to this function. And so if I go in and try to print here on line 8, it's going to run everything. Notice it still says instead of foo, about to call foo, does that 5 times, and it says done calling foo, and then it gives me counter is not defined. And that's just because it doesn't know what counter is. Okay, so counter not being defined isn't that it's not defined at all, it's just not defined inside of our scope. We typically want to declare our variables locally. What that means is it's going to be declared either inside of our parameter list, or we're going to create and use them inside of our function. We don't want to have variables that are outside of our function that are passed in. That's known as a global variable. And Python, like a lot of languages, does allow it. But global variables can cause a lot of issues. Let me give you a perfect example. Let's say that you and I are working on a project together. We're building an interactive website, and you define the price of an object, and I'm going to use a variable called price. Well, if we use global variables, Python's going to say, hey, price, I know what price is. And it's going to let me change the value that you set, and vice versa. Now, when we're trying to run our program, we're seeing that the price is never right. And what happens is you're using price maybe to keep track of a price of an individual item, and I'm using price to keep track of the total sum of all the items that are being checked out. Both of them have a logic use in that term. Could I have used a better term? Yes, I could have, but mine wasn't necessarily wrong. Because we had something where both were defined logically and at a global level, we can cause issues. How to define things at a global level? Basically, we define them where it's not inside of a function. So we don't want to do that. Avoid global variables wherever you can. Always use a variable that's local to your scope. Now you might say, well, where would a global variable be? Well, if I specified up here, counter equals 6. So here I've created a counter. This is a global level variable. It's not inside of a function. And you might go, well, okay, the counter on line 2, is that using counter as 6, or is it using the counter that's defined inside my parameter list? And if you ever have to ask yourself that question, that can cause yourself some problems. We don't want to do that, okay? I'm going to clear my screen of my terminal, run this. You'll notice that in this case, because counter was a parameter that was passed in, it did it okay, and it created a local variable that had the same name as a global variable. Yeah, that's not confusing at all, but it worked, okay? We don't want to necessarily do that. We still want to make sure that we always declare our variables locally. Now, you might be going, but wait a second, I've got these functions in here. How do I do that? Well, there's an easy way around that, actually, and that is we're going to create a new function, and typically you'll see it called main. And main is going to be the function that we are going to call when we go run our application. Now, it's not called automatically. If I save this and I run this, notice that nothing happens because main is not called. So how do we get around this? Well, let me show you. I could call main like this. And if I did this, let me clear my screen for my terminal, you'll notice that, hey, it works. But if I import my code as a library, we haven't talked about importing libraries yet. That's going to be coming up in a future module. But if I were to take this and make it into a library that could be imported, main would get called automatically. And that's a problem. We want to get around that. Luckily, Python has a great way of handling that. The way that we're going to do this and make sure that we call main when we need it is there's a built-in runtime variable for Python that's going to check and say, hey, am I the current module that's running, or was I imported? To do that, we're going to say if __name. Notice that this is something that's built into Python. That's why it showed up automatically. It's colored just like a variable, but this is something that the system sets. We don't set it. If it's equal to, so we're checking for equality, so double equals, underscore, underscore, main, underscore, underscore, put a colon. So if we're calling this module, we're not importing it. And go main. And now if I go and run it, notice it goes and runs. So this is a very standard Python coding practice. You'll see this in online examples. You'll see this if you're starting to do some work maybe in a lab and there's a Python script that's out there running. You're going to see it there. You're going to see it all over the place. And so you should expect to see this. This is a great way of checking to determine, do I need to run my main function or do I need to sit there and wait for it to be called? There's one more thing that we want to look at with our functions. So we've looked at just a plain function that takes no parameters. We've looked at functions that take a single parameter, multiple parameters, optional parameters, and we've even looked at recursive calls for our functions. You might think, well, what else could there be? And the simple answer is functions that return a value. You go, oh yeah, that. Yes, that. We want to be able to pass a value into a function and get something back. Think about all those mathematical functions that we've looked at or you've looked at in other math classes, okay? Whether it's a calculus class or a stats class, and you got to calculate your standard deviation, or you got to calculate the area under a curve, or any of those types of things, you're expecting an answer back. And a lot of times functions are going to provide the same thing. Most languages do limit you to returning a single value back from a function. So most languages are going to limit you to returning either 0 or 1 value from a function. In some cases, some languages like C, it's kind of weird. You always get a value back, even if you don't define what that value is. It's kind of weird. That's very much tied to the mathematical definition of a function. Technically, if you want to kind of split hairs, a function that doesn't return a value should be called a procedure or a sub-procedure. But in Python, it's all functions. And in fact, in most modern languages, even if you don't return a value, it's called a function. Now, notice that I said most languages limit you to returning either 0 or 1 value. Python actually allows you to return multiple values. This is kind of a bad habit in my opinion, because if you move to another language, you're limited to the single return value. And we're going to keep our functions simple. That's going to be what value we're going to return. So let's take a quick look at this. I'm going to clear out my terminal and code windows. And I'm going to create a function called sum. You might go, really? Sum? Yep, num1 and num2. And you might go, can't I just use the plus operator? And I'm like, you bet you can. But we're just keeping something simple to see a value that's returned. I can go in here and I can say total equals num1 plus num2. Now, if I do this and I come up here and I say, okay, if underscore underscore name is equal to main might say something like value equals sum 1 comma 4 print value. There's going to be 2 errors with this that you're going to want to fix. I'm going to show these real quick. Okay, so let's run the Python program and see what those errors are. We see our first one here, name error, name main is not defined. So I'm going to come up to line 5 where it says that error is. And I look and say, okay, I see main. I see on line 7 I have main. I'm going, wait a second, what's going on here? Why did this not work? Well, Python wants you to define a function before you use it. Okay, so what I like to do as a habit is all of my functions get put at the very top. Okay. Now notice that main is no longer underlined. It says, oh, I know what main is. I can do this. Yeah, we're good. All right. So let's save this. Let's run it again. And you'll notice we get back a value of none. None. If I'm summing 1 and 4, I should not be getting none. Okay. None is a built-in keyword and defaulted value inside of Python. So what's happening is in my sum function, I have a total. I say num1 plus num2. That makes sense, but I don't do anything with total. I need to return that value back out of that function. So I'm going to actually use a built-in command called return. Notice it shows up as purple, just like your if and your for and stuff like that. It's a command. And then I specify what am I returning. I'm returning total. Okay. So what happens is I come all the way down. I'm skipping my function definitions. Python's going to know about them, but we're not going to touch them until we call. Say if underscore underscore name underscore underscore is equal to main, call main. Goes up to line 5. Value equals sum of 1 comma 4. Well, I'm going to then call sum, so I go up to line 1. Okay, I got my value for num1 and num2. Parameter names can be anything I want them to be. They're like a variable name. I try to make them logical as to what they're going to be. It just makes life a lot easier. So I'm going to say, okay, total equals num1 plus num2. Oh, I know what I can do with that. I know how to add. We put those together. I return a total. Okay, we're good as far as that goes. That value gets sent to sum. And remember, whenever we have a single equals, it's the assignment operator. We're moving what's in the right-hand side to the left-hand side. And so I say, oh, sum. Okay, let me put that into value. That variable now holds a value. Okay, the value of that sum function. And then we can pass that value, that what was sent to us, what was returned to us, into our print statement. So now that I have that return value and I specify return total, it goes through that whole process. And you can see that, hey, I got 5. If I change my value in main to be 3, 3 plus 4 is 7, and it prints it out. And I can make those changes as much as I want to. I could go further into this list, and there's ways I can do that. I'm not going to bother with that at this point. You know, I could say, well, what happens if I want to pass in 3, 4, 5, 6 values to the sum? There's actually ways that you can create a near limitless amount of parameters that can be accepted. Once again, that's probably more of like a fast walk, jog type of thing. We're just learning to kind of stretch our legs, just learning to walk here. So we're not going to worry about that at this point. We're going to focus on the fact that, hey, I have a main function. My main function calls some, returns a value back to me. I can capture that. I can put it inside of a variable to be used later. I could put that directly inside of a print statement if I wanted to and say print sum 3 comma 4. That would also technically work. But I'm just doing a simple step by step by step, starting off slow, letting us build our conceptual knowledge to understand what the computer is doing so we can then move forward from there. It's a very simple process. We use this all the time, and returning values from functions is very important. Now, like I said, typically we're going to return a single value. Now, that value can be very large and complex, or it can be a simple thing like a number like you see there. So what data is returned and how we return it is very much based upon what the function is that we're going to do. But this is a great example of how we're going to do it. So in this module, we've looked at functions. We've looked at how to create a simple function, how to call that function. We've looked at how to pass in parameters, both single and multiple parameters. We've looked at optional parameters. We've looked at returning values. We've looked at using the main function so we can understand our local scope and reduce the chances and need of global variables so our code is cleaner and easier to work with. The last thing I do want to point out, just to let you know, is you might be looking at this going, I don't see this as something that's going to speed me up. You know, I see a few extra lines of code and I'm having to do this. Why would I do this? Well, the answer becomes in what job you're processing. So recently I was helping a student of mine. There was a Python script that generated some graphs, and they were trying to get the numerical values out of this. Well, they had these complex equations that were being calculated in order to figure out what the graphing values were. And so instead of getting a graph, we were looking to how do we determine what that number is that they're looking for. They were looking for some magic special values. What those were is beyond the scope of this. But what we had to do is we had to look and say, well, how's this going to be? Well, they would go through lots and lots of data, different types of solutions that they were mixing to get all these different graphs. Those could be put and were put inside of functions in order to generate that graph. So when we do it one time like we see here, it's not really beneficial. When we do it multiple times, 2, 3, 4, 20, 50, 100 times, sometimes more, becomes very, very beneficial. And when I worked as a professional developer, this was the type of things that we saw all the time and figured, okay, how can we do this? Now, I am going to be honest with you. Using a function is going to slightly slow down your programming code. However, with the modern speed of your modern computers and what a processor does, this is inconsequential. Your time as a developer has a certain amount of value attached to it. So if I am a software company and I'm paying you a certain amount of money per year, every hour you're working, you are costing me a certain amount of money. My goal is to generate a product that's going to make more money than what you cost me. So I have to look and say, well, you may have been a little bit faster, maybe 0.5% faster because you didn't use a function call, but it took you 3 times longer to write this code. Is that a good trade-off? Well, probably not. And so I'm going to look at it from a managerial perspective and say, no, I want you to write code quickly because the cost of a computer and its processing time versus the cost of you as a software developer, the computer hardware is cheap. You, the developer, that's where we want to be efficient. And when we do something over and over and over again, which is what you see in a real life example, functions are always the way to go. So just keep that in mind. You have a certain cost associated with it. Your processing power has a certain cost associated with it. Almost every time, your cost is more than a computer, so be efficient. Reuse those functions. We're going to continue to see functions time and time again through our future modules, both built-in functions as well as functions we're going to write. So get this down good. Look at the smaller sections if you need to. Review them. Review this module again if you need to. And I will see you in the future.